Hello, in this lecture we'll find out the orange area of the orange shape using two different methods. In the drawing we have square ABCD. One side of square ABCD equals to 10 units. Inside the square we have semicircle APD, and we have another semicircle that is DPC, and the two semicircles are perpendicular to each other, and we also have a quarter circle ADQB, and our mission is to find out the area of this orange shape. Okay, so we start with the first method, but first of all I will present to you or explain to you what is the area of a sector. If we have this sector in the green color, we have the sector in the green color. The area of this sector equals to, we know that the radius of this circle is r, so the area of this sector equals to pi r squared, that is the area of the circle, times theta, that is the angle between the two sides of the sector, over 2 pi. 2 pi is in radians, and it is equal to 360 degrees. So when we divide the angle theta by 2 pi, we get the ratio of the area of the sector, and if we divide that ratio by pi r squared, we get the area of this sector. That's actually the area of the green sector. Okay, so the area of the green sector equals to pi r squared times theta over 2 pi. Theta is the angle between the two sides of the sector. Over 2 pi is 360 degrees in terms of radians. Okay. For example, if theta equals to pi radians, it means that theta equals to pi, so pi over 2 pi is 1/2, and we get that we have a semicircle. Here it is not a semicircle, it is less than semicircle. It is the angle theta over the angle that is equal to 360 degrees, to theta radians equals to 360 degrees times the area of the circle, that is pi r squared. Okay, and the next term that I want to explain to you is the area of a circular segment. The green shape is a circular segment, and the area of this green shape or circular segment will be equal to the area of sector A or B, the area of this sector, minus the area of triangle A or B. If you subtract from the area of sector A or B the area of triangle A or B, we will get exactly the area of the circular segment ASB. The area of circular segment AB. Okay, so again, the area of circular segment AB in the green shape equals to the area of sector A or B minus the area of triangle AOB. Will give us the area of the green shape, that is the area of the circular segment AB. Okay, so here in the next step we will draw here from the center of this semicircle. We'll start with the first method, and in the next step we will find out the area of geometrical lengths. Okay, so when two circles intersect with each other, they create a length, and we find out the area of the length, and we will subtract the area of the big length from the area of the big length, that is actually the big length that includes that contains the blue length and the orange shape. We will subtract from this the area of the big length, we will subtract the area of the blue length. In this way we get the area of the orange shape, because the area of the big length minus the area of the blue length will be equal to the area of the orange shape. Okay, so we will try to develop a formula that is good for the area of a length in general, and then we will put in this formula the area of the big length, and we subtract from the area of the big length, this big length, the area of the blue length. In this way we get the area of the orange shape. Okay, so first of all, from the center of this semicircle APD, we will draw tangent perpendicular to the touching point here. So here the radius that is equals to this point is O. O is the center of the semicircle. P is a point on the semicircle itself, so OP is the radius. So we will define the radius of this semicircle as A. So it is A, and here the radius OP that is equal to A, it is drawn to the point of tendency, that is to say it is drawn to point P, that is the point of tendency of tangent here. So this is the radius, OP is the radius, and the radius is tangent to this semicircle DPC. So likewise, from the center of this semicircle CPD, we will draw radius that will be tangent to this semicircle at point P. So again, here we have the radius OP that is drawn to the point of tendency, that is to say it is drawn to point P, that is the point of tendency of tangent NP in this circle. And whenever you have a radius that is drawn to the point of tendency, then this angle will be equal to 90 degrees. Tangent NP will be perpendicular to the radius OP. So NP is perpendicular to the radius PO, it means that this angle equals to 90 degrees. And likewise we have, we know that the radius OD, it is drawn to the point of tendency, that is to say it is drawn to point D, that is the point of tendency of tangent AD with this semicircle. And whenever you have a radius that is drawn to the point of tendency, then tangent AD will be perpendicular to the radius OD. So that if OD is, if ND is perpendicular to the radius DO, it means that this angle must be equal to 90 degrees. Okay? And we define the radius of the semicircle CPD as B, and the radius of the semicircle DPA is defined as A. So NP starts from the center of the semicircle and ends at point P, that is the point of the semicircle itself. That is to say, it is also the radius of this semicircle that is equal to B. Okay? So we will join points D and P together by a straight line. And first of all, we will find out the area of segment, circular segment, this circular segment, and when we multiply it by 2, it will give us the area of the blue lens, because those two shapes are identical, therefore they have also the same area. So the area of segment, circular segment, this circular segment here, the area of the upper circular segment it is equal to the area of sector DOP of sector DOP. Write it now. That is actually this shape, the area of sector DOP. This is the shape of the area of sector DOP. This angle equals to 90 degrees minus the area of triangle DOP. That is a right triangle. And when we multiply it by 2, we will get the area of the blue lens. Okay, so what is the area of circular segment DP? It will be equal to the area of sector DOP, that is actually equals to it is a quarter circle, therefore it is equal to pi times the radius of this semicircle square over 4. So it will be equal to pi times a squared, that is the radius square, over 4. Because if the area of any circle equals to pi r squared and r equals to a, it means that the area of a quarter circle, this is a quarter circle, DP is a quarter circle, the area of the quarter circle will be the area of the circle over 4 minus the area of the right triangle DOP. But because of the fact that we know that one side of square ABCD equals to 10 units, and point O is the center of the side of the square, it means that the radius will be equal to 5. The radius of this semicircle equals to 5. So therefore, both sides of the right triangle DOP are equal to 5. This angle equals to 90 degrees, and both sides of this triangle equals to 5. So the height is 5 and the base is also 5, so it is 5 times 5 over 2. So we actually found out the area of this circular segment. And when we multiply it by 2, we'll get the area of the lens, the area of the blue lens. The area of the blue lens is equal to 2 times the area of circular segment here. Actually, I started here in the second method, but it is okay because after I finished with the second method, I'll continue with the first method. Here, so the area of the blue lens, the area of the blue lens, this blue lens, again a lens is the common area that will be created when two circles intersect with each other. When two circles or semicircles intersect with each other, they create a common area. The common area is the blue lens. Okay? So here we know that A equals to 5, so it is pi, and A is 5, so A squared is 5 squared, that is 25 over 4 minus 25 over 2. Now we multiply the area of this circular segment by 2, and we'll get the area of the blue lens. This is the blue lens. So the area of the blue lens will be equal to 2 times the area of a circular segment, because they are identical. We can multiply the circular segment by 2 and we get the area of the blue lens. So here we have pi times 25 over 4 minus 25 over 2, all multiplied by 2. So when multiplied by 2, we'll get that 25 pi times 2 over 4. So we'll divide both the numerator and the denominator by 2, and we get that it is 25 and 4 over 2 is 2. And here we have 2 times 25 over 2. 2 over 2 is 1, so it is minus 25. So in conclusion, we found out that the area of the blue lens, this blue lens equals to 25 over 2 is 12.5, so it is 12.5 pi minus 25. In conclusion, the area of the blue lens equals to 25 pi 12.5 pi minus 25 square units. Okay, so in the next step we will find out the area of the big lens. The area of the big lens consists of the area of the blue lens plus the area of the orange shape. Okay, so we'll find out the area of the blue lens, and then we'll subtract the area, we'll find out the area of the big lens, this lens, and we'll subtract from the area of the big lens the area of the blue lens, and the area of the big lens minus the area of the blue lens equals to the area of the blue shape, that is dpq. Okay, so our mission is to find out the area of the big lens that consists of the black and the blue lens plus the orange shape. Okay. So we know that every side of the square is equal to 10 units, so this side equals to 10. We actually want to find out the area of this shape. This is the area of the big lens. Okay. So we will join this point. We join this point with the center of this semicircle. And from this point we will draw tangent to the intersection point here. Actually, we know that the radius of the quarter circle equals to 10 units. So here, this is the radius of the quarter circle, that is equal to 10 units. Because of the fact that this is a quarter circle, it means that this circle also equals to 90 degrees. Here actually the semicircle is perpendicular to the quarter circle. Okay, therefore we have here 90 degrees. And we know that the radius of the semicircle equals to 5 units, so here we know that this is 5, this is the radius of the semicircle, and this is also the radius of the semicircle that is equal to 5 units. Here, this is the tangent, and here, this is the tangent, and this is the radius, so the radius is always perpendicular to the tangent, so this angle equals 90 degrees. Actually, those two triangles can go into each other according to side rule. Those two sides are equal to each other, they are both equal to 10 units. Those two sides are also equal to each other, they are both equal to 10 units, to 5 units here. And this is the common side that belongs to both triangles, so those two triangles can go into each other according to side rule. So if we define this angle as theta, then this angle must be also equal to theta. Okay, so we will join the 2 points together here. In the first step, we'll find out the area of this circular segment. So this angle equals to theta plus theta is 2 theta. So here the area, so here actually now our mission is to find out the area of the big lens. This is the big lens, and we will do it in 2 steps. First of all, we will find out the area of this circular segment, the upper circular segment. Then we find out the area of the lower circular segment. We will add them together. In this way, we will find out the area of this big lens, and then we will subtract the area of the big lens from the area of this big lens. We will subtract the area of the blue lens. We have already found out that the area of the blue lens, it is equal to 12.5 pi minus 25. So we'll subtract from the area of the big lens the area of the blue lens. In this way, the area of the big lens, this is the big lens, minus the area of the blue lens equals to the area of the orange shape, that is dpq. Okay, so now our mission is to find out the area of the upper circular segment in the big lens. So the area of the upper circular segment will be equal to, so here this is the green circular segment that we want to find out. And the area of this green circular segment will be equal to the area here, L, M, O. So will be equal to the area of sector L and O. This is actually this shape, the area of the sector. know that the angle between the legs of the sector is equal to pi plus pi is 2 pi. Theta plus theta is 2 theta. This is the angle between the legs of the sector. And here we have to subtract from the area of this sector the area of the triangle LNO. So I write it here. I write here that this is the area of triangle LNO. The angle is here is 2 theta. So it is very easy to see from the drawing that if we subtract from the area of this sector actually L and O, if we subtract from the area of sector L and O the area of triangle L and O, it will give us exactly the area of this circular segment that is Ln, the area of the green circular segment. Okay, so what is the area of the sector? The area of the sector, it is equal to, according to the formula that I showed to you, it is equal to pi r square. Here r is 10, so it is pi times r square is 10 square over 2 pi actually it is 2 theta over 2 pi, 2 theta over 2 pi. The area of this sector equals to 2 theta over 2 pi times the area of the circle, that is pi 10 square. Repeat again, the area of the angle between the legs of the sector, that is 2 theta over 2 pi, that is in radians, and in terms of degrees it is equal to 360 degrees, times the area of this of the circle, that is pi r square, and r equals to 10, so it is pi 10 square. So that is the area of this sector minus the area. So here this equals to 10, and also this equals to 10. So minus the area of triangle LON. The area of triangle LON equals to the multiplication of its sides by each other. That is 10 times 10 is 10 square, times sinus 2 theta over 2. So in conclusion, we found out that the area of this circular segment equals to this expression. So here we have theta in the numerator and we have theta in the denominator, so it will get cancelled. So here we get that after we cancel theta, what is left from this expression? What is left is actually 10 square over 2 times 2 theta minus 10 square over 2, and according to the trigonometric identity, sinus 2 theta equals to 2 sinus theta cosine theta. Okay, so we substituted sinus 2 theta to 2 sinus theta cosine theta. So we will analyze the triangle OPL. So copy it here. LO is the radius of the quarter circle that is equal to 10 units. It is also the side of the square. This is angle theta. LP equals to 5 units. This is the right angle. So in this right triangle LOP, we'll get that tangents theta equals to LP over LO. LP is 5, LO is 10, 5 over 10 is 0.5. So in conclusion, we found out that tangents theta equals to 0.5. Here we will operate the opposite function of tangents on the result that is 5, that is 0.5, and we will get that tangents minus 1 is the opposite function of tangents. We'll operate this opposite function on the result that is 0.5. In this way, we will get theta. Okay? So here we found out the equation that tangents minus 1 on 0.5 equals to theta. And according to the pattern, if we implement the Pythagoras theorem on this right triangle LOP, that is to say 10 square plus 5 square equals to PO square. That is to say PO equals to the square root of 10 square plus 5 square. Square root of 10 square plus 5 square is square root of 125, and 125 is 25 times 5. The square root of 25 is 5. So in conclusion, we found out that the hypotenuse equals to 5 times square root of 5. Okay. So here we have, so what is the value of sinus theta? The value of sinus theta, from the drawing you can see that the value of sinus theta is 5 over the hypotenuse, that is 5 over square root of 5. So here we get that sinus 2 theta equals to 2 times sinus theta, but according to this drawing, the value of sinus theta is 5 over 5 times square root of 5. times cosine theta. Here, times cosine theta. So cosine theta equals to here 10 over the hypotenuse, that is 5 times square root of 5. So in conclusion, I found out that sinus theta equals to here 5 over 5 is 1, so 5 will get cancelled. So here we have 2 times 10 over square root of 5 times square root of 5 is 5, so it is 5 times 5. So we have 2 times 10 over 5 is 2. So it is 2 times 2 over 5, so it is 4/5. In conclusion, I found out that sinus theta equals to 4/5, while tangents, the opposite function of tangents, that is tangents minus 1, when we operate the opposite function on 0.5, it will give us angle theta itself. Okay, so now we can actually substitute angle theta in the previous equation by tangents minus 1 times 0.5, and we can substitute sinus 2 theta by 4/5. So I'll copy again the equation that we got. We have the equation that actually the area of the blue of the circular segment, the upper side of the circular segment of the big lens, we found out that the area equals to 10 square, that is 100 over 2 is 50, times 2 theta, times 2, and according to this equation, theta equals to tangents minus 1 of 0.5. So we substitute theta in the original equation by tangents minus 1 of 0.5, and we also have to subtract 10 square is 100, and 100 over 2 is 50. So here we have 10 square. Here 2, we have 2 in the numerator and 2 in the denominator, so 2 will get cancelled, and we left only with 10 squared, that is 100. Actually, here this expression 2 sine theta cosine theta equals to sine 2 theta. So here we have 10 square over 2 is 50. 10 square over 2 is 50. And we have already found out that 2 sine theta cosine theta, that is sine 2 theta, it is equal to 4/5. So we substitute this expression that is equal to sine 2 theta by 4/5. So here we get that 50 times 2 is 100 times tangents minus 1 of 0.5 minus 50 over 4, 50 over 5 is 10, and 10 over 4 is 40. So in conclusion, we actually found out that the area of the upper part of the big lens, the area of this circular segment, that is the upper part of the big lens, is equals to 100 times tangents minus 1 of 0.5 minus 40. So in the next step, we'll find out the area of the lower circular segment. Okay? We found out the area of the upper circular segment. In the next step, we'll find out the area of the lower circular segment of the big lens. And after that, we will join the two parts together. In this way, we'll get the big lens, the area of the big lens. So here, our mission is to find out the area of the lower circular segment of the big lens. LP is the radius of the semicircle that is equal to 5 units. Here PN is also the radius of the semicircle that is also equal to 5 units. Those two angles are equal to theta. So if you focus on the right triangle DLN, this angle equals to theta, this angle equals to 90 degrees, that is actually in terms of radians is pi over 2. So this angle must be equal to pi over 2 minus theta. In order to complete the sum of the angles in this right triangle to 180 degrees, this angle must be equal to 180 degrees. Pi over theta minus theta. Pi over 2 minus theta. For the same reason, this angle must be also equal to pi over 2 minus theta. Actually, those two right triangles can go into each other, and anyway, those two angles must be equal to each other. Okay, so here we have what is the size of angle LPN, the size of the big angle LPN. It is equal to the sum of those two angles, pi over 2 minus theta plus pi over 2 minus theta. Pi over 2 plus pi over 2 is pi. Minus theta plus minus theta is minus 2 theta. So in conclusion, we found out that this angle equals to pi minus 2 theta. Okay, so what will be the area of the green circular segment? The area of the green circular segment is very easy to see from the drawing that the area of the green circular segment will be equal to the area of sector LPN. This sector, I will draw the sector here. The area of sector LPN this is sector LPN. We know that the angle between the legs of the sector is pi minus 2 theta. Each leg equals to 5 units. This is the radii of the semicircle minus the area of triangle LPN. It is very easy to see from the drawing that if you subtract from the area of this sector the area of triangle LPN, you will get exactly the area of the green circular segment. So I will draw the triangle LPN. This is triangle LPN. Okay. Repeat again. When you subtract from the area of sector LPN the area of triangle LPN, you will get exactly the area of the green circular segment. Okay? So now we will calculate the area of each item. So here the area of sector LPN, the area of sector LPN, it is equal to, according to the formula that I presented to you, the area of sector LPN equals to here the angle between the legs of the sector is pi minus 2 theta. We have to divide it by 2 pi, that is 360 degrees in terms of radians, and we have to multiply it by the area of the circle, that is pi r square. R equals to 5, so it is pi times 5 square. In conclusion, the area of sector LPN equals to pi minus 2 theta over 2 pi times 5 square. Here we have pi in the numerator and pi in the denominator, so pi will get cancelled. And we have to subtract from the area of the segment LPN the area of triangle LPN. The area of triangle LPN equals to the multiplication of the sides of the triangle by each other, that is 5 times 5, that is 5 square, times sinus the angle between the two sides, that is actually angle pi minus 2 theta, all divided by 2. Okay, so here actually found out that the area of the lower circular segment in the big lens equals to this expression. So here we will open the brackets. Here pi times 5 squared is 25 over 2 minus 2 theta times 25 over 2. 2 over 2 is 1, so it will get cancelled. Minus 25 over 2. According to the algebraic identity, that sinus pi minus 2 theta equals to sinus 2 theta. So we can substitute sinus pi minus 2 theta by sinus 2 theta. So here we actually found out that the area of the lower circular segment in the big lens equals to 25 over 2 is 12.5, so it is 12.5 pi minus 25 theta minus 25 over 2, and we already found out that sinus theta equals to 4/5. So we'll substitute sinus theta by 4/5. So here we actually found out that the area of the lower circular segment of the big lens equals to 25 pi minus 25, and we have already found out that tangents theta equals to the opposite function of tangents of 0.5. So we can substitute theta here by tangents minus 1 of 0.5, and here 25 times 4 is 100. In the denominator we have 2 times 5, that is 10. 100 over 10 is 10. So in conclusion, we found out that the area of the lower circular segment of the big lens equals to 12.5 pi minus 25 tangents minus 1 of 0.5 minus 10. Okay, now we can add the area of the upper circular segment to the lower circular segment, and in this way we'll get the area of the big lens. Okay, the area of the big lens here, this big lens so here the area of the big lens, this is the big lens that's composed from the blue lens and the orange shape. it is equal to the area of the upper circular segment. The upper circular segment, we have already found out that the upper circular segment equals to 100 times tangents minus 1 of 0.5 minus 40 plus the area of the lower circular segment that we already found out that it is equal to 12.5 pi minus 25 times tangents minus 1 of 0.5 minus 10. So this is the area of the big lens. The area of the upper circular segment plus the area of the lower circular segment equals to the area of the big lens. So here we have 100 tangents minus 1 minus 25 tangents minus 1. So 100 minus 25 is 75. So it is 75 tangents minus 1 of 0.5. Minus 40 minus 10 is minus 50. Plus 12.5 pi. Now we will subtract from the area of the big lens, the composed of the area of the blue lens plus the area of the orange shape. We subtract from the area of the big lens the area of the blue lens. And in this way we get the area of the orange shape. Very simple. Okay? So the area of the orange shape, that is actually DQP, it is DQP or DPQ, equals to the area of the big lens minus the area of the blue lens. This is the blue lens. Okay? So we already found out that the area we already found out that the area of the big lens equals to 75 times tangents minus 1 of 0.5 minus 50 plus 12.5 pi. Now we have to subtract from the area of the big lens the area of the blue lens. So the area of the blue lens we have already found out at the beginning of the lecture that the area of the blue lens we have already found out that the area of the blue lens equals to 12.5 pi minus 25. Okay, so we actually have the answer here. So the answer is that the area of the the area of the orange shape, that is DPQ, equals to 75 times tangents minus 1 of 0.5 minus 50 plus 12.5 pi. Here we will open the brackets here, so here it will be minus 12.5 pi, minus and minus is plus, so here we will have plus 25. Okay, so here we have 12.5 pi minus 12.5 pi, that is 0, so it will get cancelled. And in conclusion, we actually found out that the area of the orange shape, dpq, the area of the orange shape, dpq, the area of this orange shape, dpq, equals to 75 times tangents minus 1 of 0.5. Here we have minus 50 plus 25 is minus 25. So in conclusion, the area of the orange shape is actually, it should be the second method. It is equal to 75 times tangents minus 1 of 0.5 minus 25. So what is the value of tangents minus 1 of 0.5? It is actually equals to 0.463647,609, and then we have to multiply it by 75. So we multiply it by 75. So we got 34.77. So here this expression equals to 34.77 minus 25. And 34.77 minus 25, it is 9.77 square units. Okay, so I repeat again. The area of this orange shape equals to 9.77 square units. We finished with the first method. In the next step, I will present to you how to find out the area of the orange shape according to the second method. Okay. So actually, we will find out a general formula for the area of a lens, and then we will use the general formula in order to find out the area of the big lens, and we will subtract from the area of the big lens that's composed from the area of the blue lens plus the area of the orange shape. We will subtract from it the area of the blue lens. Okay, so here Actually, when from the center of the semicircle, when we draw perpendicular to the diameter, it will be tangent to the other semicircle at the touching point here. So here we have tangent to this semicircle, that is here we have, and this is the radius OM. So first of all, we define the radius of this semicircle as A, and we define the radius of this semicircle as B. So this is also the radius, because it starts from the center of the circle and ends at point M, that is the point on the semicircle itself, so it is also equals to A. And this is also the radius of this semicircle, because it starts from the center of the semicircle and ends at point M, that is the point of the semicircle itself. So this is B, that is the radius of this semicircle. So here we have the radius OM, that is B, it is drawn to the point of tendency, that is to say it is drawn to point M, that is the point of tendency of tangent LM with this radius, with this circle, with the semicircle. And whenever you have a radius that is drawn to the point of tendency, then tangent OM must be perpendicular to the radius OM, and tangent LM must be perpendicular to the radius OM. See, if LM is perpendicular to OM, it means that this angle equals to 90 degrees. Okay. Likewise, we have here the radius ON, it is drawn to the point of tendency. That is to say, it is drawn to point N, that is the point of tangency of tangent LN with this semicircle. And whenever you have a radius that is drawn to the point of tendency, then tangent LN will be perpendicular to the radius NO. So if LN is perpendicular to NO, it means that this angle equals to 90 degrees. Okay. So we want to find out in general the area of this lens. That could be actually any lens. Okay. So how we can find out the area of this lens? So first of all, we find out, so the area of this circular segment. So the area of this circular segment NM will be equal to the area of sector NLM minus the area of triangle NLM. Okay. Repeat again. The area of this green circular segment equals to the area of sector NLM minus the area of triangle NLM. This is the right triangle, triangle NLM. Okay. And what is the area of the orange circular segment? The area of the orange circular segment it will be equal to the area of sector NOM. This is sector NOM. NOM minus the area of triangle NOM. This is this triangle NOM. NO equals to B, it is the radius of the semicircle. MO also equals to B, it is also the radius of the semicircle, this semicircle. Here LN equals to A, it is the radius of this semicircle, and LM equals to A. Okay. So you actually have to add the area of the green circular segment to the area of the orange circular segment. In this way we will get the area of this length. That is in general the area, it could be the area of any length. Okay. Now we find out the area of this sector, sector NLM, so here the area of sector NLM will be equal to the angle between the two sides, the two at the eye. It is actually unknown. It is not 90 degrees, so it will be equal to this angle, that is this angle equals to angle so here actually we don't know what is the angle here, so we'll join points O and L together by a straight line. And we define this angle as theta. So those two triangles, triangle LNO and triangle LMO, can go into each other. Therefore those two angles must be also equal to each other. So if this angle is theta, this angle must be also equal to theta. Okay, and if you focus on the right triangle, triangle L and O, here tangents theta will be equal to B over A. So triangle theta equals to B over A. And if we operate the opposite function of tangents on the result, we get the tangents on one of B over A equals to theta. So the area of circular segment L and M will be equal to 2 theta over 2 pi times pi r squared, r equals to a, so it is pi a squared. Okay, so the area of sector LNM equals to 2 theta over 2 pi over pi a square. So here we have pi in the numerator and pi in the denominator, so here the area of sector L and M will be equal to a square times theta and the area of sector NMO here it is, NO is B, NO is also B, so this angle, if this angle equals to 90 degrees, this angle equals to theta, then this angle must be equal to pi over 2 minus theta, and this angle equals to theta, this angle equals to 90 degrees, so this angle must be equal to pi over 2 minus theta. So in conclusion, here theta over 2 plus theta over 2 is pi over 2 plus pi over 2 is pi. Minus theta plus minus theta is minus 2 theta. So this angle, the angle between the legs of the sector NOM, is pi minus 2 theta. And the area of sector NOM will be equal to pi minus 2 theta over 2 pi times pi r square, and r equals to b, so it is pi b square. Repeat again, the area of sector NOM of sector NOM equals to pi b square times pi minus theta over 2 pi. So here we have pi in the numerator and pi in the denominator, so pi will get cancelled. We'll open the brackets here and we get that this pi b square over 2 minus 2 theta b square. So this is the area of sector NOM, and the area of sector NNM is a square times theta. Actually 2 theta times b square over 2, and it is equal to pi b square over 2 minus theta times b square. Okay, so we found out the area of sector NOM sector NOM and sector NLM. Okay. We found out the area of the two sectors. Actually, we have to add the areas of the two sectors together, and we have to subtract the area of the two triangles. So here we have to subtract the area of triangle NLM and also the area of triangle NOM. So actually, the sum of the areas of the two sectors minus the area of the two triangles will give us the area of this length. So here we will add the two triangles together and we will form quadrilateral NLNO. Okay, we will form quadrilateral NL quadrilateral NL M O. So actually have to subtract the area of this quadrilateral from the sum of the areas of the two sectors. Okay. Actually, those two angles are right angles. This is not here, but those two angles are right angles. So we'll join points L and O together by a straight line. The sum of the areas of the two triangles that we have to subtract from the area of the two sectors, it is actually the area of quadrilateral NOLM. The area of quadrilateral NOLM consists of two right triangles. So this is the first right triangle, and this is the second right triangle. So we'll actually calculate the area of the two right triangles. We will add the areas of the two right triangles together, and in this way we have the area of this quadrilateral that is actually equals to the area, to the sum of the areas of the two triangles. So what is the area of the green right triangle? It is equal to the base of the triangle that is A times the I to the base that is B, all divided by 2. What is the area of the orange right triangle? It is the base that is A minus the I to the base that is B over 2. So the area of the two triangles is a times b over 2 plus a times b over 2. This is to say, it is equal to AB. So the area of the two triangles equals to a times b. So we actually have the two sectors. So the area of the length will be equal to the area of the two sectors, that is actually a squared times pi. This is the sector NNM plus the area of sector NOM, that is actually pi b squared over 2 minus theta b squared. And we have to subtract from the area of those two sectors the area of the two triangles. And we know that the area of the two triangles equals to a times b. What is a times b actually? A is the radius of one semicircle, and b is the radius of the other semicircle. So it is actually the multiplication of the two radii by each other. Okay, so in conclusion, we found out that the area of a length, it is equals to a square. So here we take theta as a current factor, theta. So inside the brackets we have here a square. Here, from this expression we left only minus b square plus b times pi times b square over 2 minus ab. So the area of a length equals to this expression, but we have already found out that theta equals to tangents minus 1, that is the opposite function of tangents, b over a. So we can substitute theta by tangents minus 1 of b over a. Here we'll do it now, and we'll get that the area of the length could be any length. It is equal to a square minus b square times theta, that is actually tangents minus 1 of b over a, plus pi b square over theta minus ab. This is a general formula for the area of a length. Okay, and what is the area of the orange shape? What is the area of the orange shape? As we already I mentioned to you in the second method, the area of the blue shape equals to the area of the big length minus the area of the blue length. Again, the area of the big length that composed of the area of the blue length plus the area of the orange shape minus the area of the blue length will give us the area of the orange shape. Okay, now we'll use this formula in order to find out the area of the big length. Here, the radius of the quarter circle is equal to 10 units. That is to say, here a equals to 10, and the radius of the semicircle equals to 5 units. So b equals to 5. So we'll put the data inside this formula and we'll find out the area of the big lens. Okay, so the area of the big lens will be equal to a is 10, so a squared is 10 squared minus b squared. B is 5, so b squared is 5 squared, all multiplied by tangents minus 1. B is 5, a is 10, so 5 over 10 is 0.5, plus pi, b is 5, so b squared is 5 squared, that is 25, over 2, minus a times b. A is 10, b is 5, so it is 10 times 5. So in conclusion, we get that the area of the big lens will be equal to 10 squared is 100, 100 minus 5 squared, that is 25, so 100 minus 25 is 75, times tangents minus 1 of 0.5 plus 25 over 2 is 12.5 pi minus 10 times 5 is 50. So in conclusion, the area of the big lens equals to 75 times tangents minus 1 of 0.5 plus 12.5 pi minus 50. Now we find out the area of the blue lens, and we'll subtract from the area of the big lens the area of the blue lens, and this is the area of the orange shape. Here, the area of the big lens that is consists of the blue shape and the orange shape, this shape minus the area of the blue lens will give us exactly the area of the orange shape that we are looking for. Okay, so now what is the area of the blue lens? The area of the blue lens, here the radius, actually the blue lens created by the intersection of the two semicircles with each other. So each radius equals to 5. So A equals to 5 units and B also equals to 5 units. So the area of the blue lens, according to the formula that we have already found out, it will be equal to A is 5, so A squared is 5 squared, minus B squared, this is also 5 squared. This expression will be equal to 0, so I will write it anyway, times tangents minus 1, B is 5 and A is 5, so 5 over 5 is 1, plus pi times B is 5, so B, 5 squared is 25, over 2 minus AB. A is 5 and B is 5, so 5 times 5 is 25. So here 5 squared minus 5 squared is 0, so this expression equals to 0. So the area of the blue lens will be equal to 25 over 2 is 12.5 times pi minus 25. Okay, now we subtract from the area of the big lens of the area of the blue lens, and this way we'll get the area of the orange shape. That is actually area of shape DPQ. Here DPQ. It is equal to the area of the big lens equals to 75 times tangents minus 1 of 0.5 plus 12.5 pi minus 50 minus the area of the blue shape, that is actually equals to 12.5 pi minus 25. So here we'll open the brackets here and we'll get that the area will be equal to 75 times tangents minus 1 of 0.5 plus 12.5 pi minus 50. Here we'll open the brackets, so here we'll get minus 12.5 pi. Minus and minus is plus, so it is plus 25. Okay, so actually we found out that the area of the orange shape equals to 75 times tangents minus 1 of 0.5. Here we have 12.5 pi minus 12.5 pi is 0. And minus 50 plus 25 is minus 25. So in conclusion, we found out that the area of the orange shape, that is actually the shape that is DPQ, equals to 75 times tangents minus 1 of 0.5 minus 25. So tangents, the opposite function of tangents of 0.5 in terms of radians, it is actually equals to 0.463647609. This is the value of the opposite function of tangents on 0.5 in terms of radians. Now we have to multiply tangents minus 1 of 0.5 by 75. We multiply it by 75. It is equal to 34.77. Okay, 34.77 is 75 tangents minus 1 of 0.5 minus 25. It is the area of the orange shape. This is actually 34.77 minus 25 equals to 9.77 square units. Okay, so we actually found out the area of the orange shape. This is the area of shape DPQ. According to it is actually the first method, it is actually equals to 9.77 square units. Okay, so in the next step I will summarize the lecture. So here we have square ABCD, side, one side of square ABCD equals to 10 units. Inside the square ABCD we have two semicircles that intersect with each other, and we also have a quarter circle ABQD is a quarter circle, and our mission is to find out the area of the orange shape. It is actually defined as shape DPQ, the orange shape. Okay, so in order to find out the orange shape, we actually found out the area of the blue lens minus, and we also found out the area of the big lens. So the area of the big lens minus the area of the blue lens equals to the area of the orange shape. Okay, so first of all we found the area of the blue shape. The area of the blue shape equals to the area, actually the area of a circular segment, this circular segment equals to the area of sector DOP minus the area of this triangle. So actually this is a quarter circle, and the area of a quarter circle equals to pi r square, or if a is r, so it is pi s square over 4. It is the area of the circle divided by 4 minus the area of the right triangle. We know that a equals to 5, so it is pi 5 squared, that is 25 over 4. This is the area of the quarter circle minus the area of the right triangle will give us exactly the area of this circular segment. So we actually found out in conclusion that the area of this circular segment equals to 25 pi over 4 minus 25 over 2. But because of the fact that the two circular segments are identical, the blue shape, the blue lens is composed of two circular segments that are identical in their sizes. We can multiply the area of one circular segment by 2, and in this way we get the area of the blue shape. So here we multiplied the area of this circular segment by 2, and in this way we found out that the area of the blue shape equals to 2 times 25 pi over 4 minus 25 over 2 times 2 over 2. So here we have 2 divided both the numerator and the denominator by 2, so 2 over 2 is 1. So here we have in the numerator 25 pi, in the denominator we have 4 over 2 is 2. So here this expression in total equals to 25 pi over 2 minus, here 25 over 2 times 2 is 25. So in conclusion, we found out that the area of the blue shape equals to 25 over 2 is 12.5. So this, the area of the blue shape equals to 12.5 pi minus 25. This is the area of the blue shape. Then we actually have to find out the area of the big lens that's composed of two circular segments. The upper circular segment and the lower circular segment. And the sum of the areas of the upper circular segment and the lower circular segment will give us the area of the big lens, and then we'll subtract from the area of the big lens the area of the blue lens. In this way we get the area of the orange shape. So what is the area of the upper circular segment? The area of the upper circular segment here, it is equal to the area of sector L and O minus the area of triangle L and O. So the area of the sector is equal to the multiplication of its size, that is 10 square times it is 2 theta over 2 pi minus pi r square, and r equals to 10, so it is pi times 10 square. Okay, minus the area of triangle N and O. The area of triangle N and O equals to the multiplication of the two sides times sinus 2 theta over 2. Okay, so this is the area of the upper circular segment. And then, so here, the area of sector L and O equals to it is 2 theta over pi, 2 theta over 2 pi times pi r square, and r equals to 10, so it is pi 10 square. Here theta in the numerator and theta in the denominator, so theta will get cancelled, minus the area of triangle L and O. The area of triangle L and O equals to the multiplication of its sides by each other. This is 10 times 10 times sinus 2 theta, that is the angle between the two sides, over 2. So here we have 10 square over 2 times 2 theta equals to 10 square over 2 times sinus 2 theta over 2. And sinus 2 theta equals to 2 sinus theta cosine theta. So here, then I draw the right triangle OLP here, and here triangle theta equals to 5 over 10, that is 0.5. Then we operated the opposite function on the result, and we got the tangents minus 1 of 0.5 equals to theta. Okay, and then we implemented the Pythagoras theorem on this right triangle, and found out that the square of the hypotenuse equals to 5 square plus 10 square. That is actually 5 square plus 10 square is 125. So we took a root out of this equation and found out that the value of the hypotenuse equals to the square root of 125, and 125 is 25 times 5. And the square root of 25 times 5, it is actually 5 times square root of 5. So in conclusion, we found out that the hypotenuse PO equals to 5 times square root of 5. So actually in this way we can find the value of sinus. We can find out the value of sinus 2 theta. We know that sinus 2 theta equals to 2 sinus theta cosine theta, so it is 2 times. And here sinus theta according to this right triangle equals to 5 over the hypotenuse, that is 5 over square root of 5. 5 over 5 times square root of 5 times cosine theta. Cosine theta equals to 10 over the hypotenuse, that is 5 over square root of 5. Okay, it is 10 over 5 times square root of 5. Here, 5, we have 5 in the numerator, 5 in the denominator, so 5 will get cancelled. So in the numerator we left only with 10 times 2. In the denominator we have 5 times 5. So we have 2 over 10 over 5 is 2. So in the numerator we have 2 times 2. In the denominator we left with 5. 2 times 2 is 4. So in conclusion, we found out that sinus 2 theta equals to 4/5, while tangents minus 1 of 0.5 equals to theta. Then actually found out that the area of the upper circular segment of the big lens equals to 50 times, here we substitute theta by tangents minus 1 of 0.5 minus 50 times, and sinus 2 theta equals to 4/5, so we substitute sinus 2 theta by 4/5. And in conclusion, we found out that the area of the upper circular segment of the big lens equals to 50 times 2 is 100 times tangents minus 1 of 0.5, and here we have 50 times 4 is 200, and 200 over 5 is 40. So it is minus 40. So in conclusion, we found out that the area of the upper circular segment of the big lens equals to 100 times tangents minus 1 of 0.5 minus 40. Then we found out the area of the lower lens of the lower circular segment of the big lens, that is actually will be equal to here the area of the lower circular segment in the green color. It is equal to the area of sector NPL minus the area of triangle NPL. Okay, so the area of sector NPL equals to, this again equals to pi minus 2 theta. So we have to divide pi minus 2 theta by 2 pi, and then we multiply it by the area of the circle, that is pi r square, and r equals to 5, so it is pi times 5 square. We have theta in the numerator and theta in the denominator, so theta will get cancelled, minus the area of triangle LPN. Triangle LPN equals to, the area of triangle LPN equals to multiplication of the sides of the triangle by each other, that is 5 times 5 times sinus the angle between those two sides, that is actually pi minus 2 theta, all divided by 2. Okay, then we have here, we open the brackets here. Here it is pi times 5 squared is 25 over 2, and here we have 2 minus 2 theta times 25 over 2. Okay, so here we have 2 in the numerator, 2 in the denominator, so 2 will get cancelled, and here we have 5 squared is 25 over 2 times sinus theta minus sinus pi minus 2 theta equals to sinus 2 theta, of course. Then here we have 25 over 2 is 12.5 times pi minus 25 pi minus 25 over 2 times sinus theta is 4/5, so we substitute sinus theta by 4/5 and found out that here 12.5 pi minus 25 pi, here 25 times 4, actually 25 over 5 is 5, and 5 times 4 is 20, and 20 over 2 is 10. So in conclusion, found out that the area of the lower circular segment of the big lens equals to 12.5 pi minus 25, and theta equals to tangents minus 1 of 0.5, so we substitute theta by tangents minus 1 of 0.5, that is the opposite function of theta, of tangents. Here it is minus 10. Okay. So, in conclusion, we found out that the area of the big lens equals to the area of the upper circular segment plus the area of the lower circular segment. This is the area of the big lens. It is actually here. We have 100 times tangents minus 1 of 0.5 minus 25 tangents minus 1 of 0.5, so 100 minus 25 is 75, so here we have 25 times tangents minus 1 of 0.5. Here we have minus 40 minus 10 is minus 50 plus 12.5 pi. So now, in conclusion, now the big lens equals to 75 times tangents minus 1 of 0.5 minus 50 plus 12.5 pi. And we know that the area of the orange shape, that is the area of shape PDQ, will be equal to the area of the big lens minus the area of the blue lens. So it is equal to the area of the big lens, that is equals to 75 tangents minus 1 of 0.5 minus 50 plus 12.5 pi minus the area of the blue lens, that is equals to 12.5 pi minus 25. So here we open the brackets and we found out that 75 times tangents minus 1 of 0.5 minus 50, and here we have 12.5 pi minus 12.5 pi is 0, plus minus and minus is plus, so here we have plus 25. Okay, so in conclusion we have here 75 tangents minus 1 of 0.5 minus 50 plus 25, and minus 50 plus 25 is minus 25. So in conclusion, found out that the area of the blue shape equals to 75 times tangents minus 1 of 0.5 minus 25, and we know that the value of tangents minus 1 of 0.5 is 0.46. We multiplied by 75 and found out that 75 times tangents minus 1 of 0.5 is equals to 34 times 77. And the answer to the question is that the area of the orange shape equals to 34.77 minus 25, that is 9.77 square units. So the area of the blue shape equals to 9.77 square units. So we finished with the first method. Then I presented to you how to find out the area of the orange shape according to the second method. According to the second method, we actually calculated the area of a lens that is created by two semicircles, and we created general formula for the area of a lens. And then in this general formula we put the area of the big lens, and we subtracted from the area of the big lens the area of the blue lens. This gives us the area of the orange shape. Okay, so here the area of the orange, the green circular segment equals to the area of sector NLP minus the area of triangle NLP. Okay, if you subtract from the area of this sector the area of this triangle, we get the area of the green shape, and the area of the orange circular segment will be equal to the area of sector M and O minus the area of triangle M and O. Okay. Then from here we can, if we focus on the right triangle L and O, we get the tangents theta equals to B over A. Okay, and here if I know that the area of sector N and M equals to the angle that is between the legs of the sector is 2 theta here, over 2 pi times pi a square. This to say, we got here a square times theta, because 2 will get cancelled here. We have 2 in the numerator and 2 in the denominator, so the area of sector N and M equals to a square times theta, while the area of sector NOM, the area of sector NOM will be equal to the angle that is between the legs is pi minus 2 theta over 2 theta, pi minus 2 theta over 2 pi times pi r squared, and r equals to b, so it is pi b squared. We open the brackets here, and we got that pi times b squared over 2 equals to 2 theta times b squared over 2. So in conclusion, we found out that the area of sector NOM equals to pi b squared over 2 minus theta b squared. And we actually have to subtract from the area that we get here, the sum of the areas of the two sectors. We have to subtract the area of the two triangles. So actually we combined the two right triangles together and created a quadrilateral NPLO. This quadrilateral, we join points N and P together. In this way, we created here two right triangles. Thereof each right triangle, thereof the green right triangle equals to a times b over 2, and thereof the orange triangle also equals to a times b over 2, and the sum of the areas of the two triangles is a times b over 2 plus a times b over 2, that is a times b. So in conclusion, the sum of the areas of the two triangles is a times b. So we have to subtract from the total area that we got a times b. So in conclusion, the area of any length equals to here a squared times theta plus pi b squared over theta minus theta times b squared minus ab. Here we took out theta as a common factor, so inside the brackets we have here a squared minus b squared plus pi b theta over 2 minus ab. And we have already found out that theta equals to tangents minus 1 of b over a, so we substitute theta by tangents minus 1 of b over a. So here the area of the length equals to a squared minus b squared, that is the eye of the two circles or semicircles that intersect with each other, times tangents minus 1 b over a plus pi b squared over 2 minus ab. So we have here the area of any length. So we can calculate the area of the big length according to this formula. We calculated the area of the big length. In the area of the big length we know that the radius of the quarter circle is equal to 10 units, so A equals to 10, this is the radius of the quarter circle, while the radius of the semicircle equals to 5 units. So B equals to 5. So we put here the data, A equals to 10 and B equals to 5. You got A squared is 10 squared minus B squared is 5 squared times tangents minus 1 of 5 over 10 is 0.5 minus pi times b squared times 5 squared, that is 25 over 2, minus AB. A is 5, A is 10 and B is 5, so it is minus 10 times 5. So in conclusion, found out that the area of the big length equals to 100 minus 25 is 75, so it is 75 times minus 1 of 0.5 plus 12.5 pi minus 50. Okay? And then we found out the area of the blue lens. What is the area of the blue lens? In this, we put the data in the formula for the area of any triangle. Here, the blue lens created by the intersection of the two semicircles together. So, we know that the radius of each semicircle is equal to 5. So, A equals to B equals to 5. So, A squared minus B squared is 5 squared minus 5 squared, that is 0, plus pi b squared over 2 is pi, b is 5, so b squared is 5 squared, so it is 5 pi times 25 over 2 minus a times b, that is 5 times 5 is minus 25. So in conclusion, we found out that the area of the blue lens equals to 12.5 pi minus 25. So we subtracted from the area of the big lens, that is 75 times minus 1 of 0.5 plus 12.5 pi minus 50, the area of the blue lens, that is 12.5 minus 25. Here we open the brackets and we found out that 75 times target minus 1 of 0.5 plus 12.5 pi minus 50 minus 12.5 pi plus 25. So 12.5 pi minus 12.5 pi is 0, and minus 50 plus 25 is minus 25. So in conclusion, we found out that the area of the orange shape, that is the area of shape DPQ, it is equal to 75 times target minus 1 of 0.5 minus 25. And found out that the value of target minus 1 of 0.5 is 0.46. We multiplied by 75 and we found out that 75 times target 1 of 0.5 is 34 times 77 minus 25. 34.77 minus 25, it is equal to 9.77 square units. So in conclusion, in both methods we found out that the area of the orange shape, that is actually also the area of shape DPQ, it is equal to actually 9.77 square units. Okay, thank you very much.